Hello students, today we will discuss about digital to digital signal conversion. So, the in the already we have discussed in the OSI layer, the first layer is the physical layer where the data are actually transmitted. Okay, so uh, in the digital to digital conversion, digital we convert the digital data to digital signal. Okay, Wha- what are the digital data? That means our text, our information, that means the text, number, images, audio, video, all are stored in the computer memory in the form of bits. Okay, now when they are to be transmitted, they converted into what digital signal. Okay, at that time we need the digital to digital signal conversion. That means digital data converted to digital signal. Okay, so in the figure we can see the digital data is 0 1 in the form of 0 and 1, and here is the digital signal. Okay, at the sender side we need digital to digital signal conversion, and at the receiver side we need digital signal to digital data conversion. Okay, so how this is done? Okay, so this conversion technique is of three types: line coding, block coding, and scrabbling. Here we discuss about line coding techniques. Okay, so in the line coding technique we have five techniques are involved here: unipolar, polar, bipolar, multi-label, and multi-transition. In each of the methodology we have different techniques in works. For example, in unipolar we have energet, non-return to zero. In polar also we have non-return to zero, return to zero, and biphase technique. Okay, next in bipolar we have AMI and pseudo ternary, and in multi-label 2B 1Q, 8B 6D, and 4D PAM 5. In multi-transition we have MLT3. So we'll discuss one by one technique. In the unipolar scheme we will discuss about unipolar scheme. That means, as the name suggests, it has one polar. That means here we can see the signal are to be converted, are represented in one coordinate only, one um, one coordinate. Okay, so non-return to zero, non-return to zero. Okay, so this is a very traditional technique where the positive voltage is represented 1 and negative voltage is represented 0. Okay, so 1 is represented as 1 and 0 is represented as like this: 1 1 then 0. Okay, so this is what the unipolar scheme. Polar scheme, as the name suggests, we have two label for this. Voltage label 0 can be positive, and voltage label 1 for negative. Okay, so here we have polar non-return to 0. Polar non-return to 0 is again divided into energet L and energet I. Energet L means energet non-return to 0 label, and energet I is non-return to 0 inversion. Okay, so we'll see how this is done. Non-return to 0, non-return to 0 L. L means label. Okay, here the voltage determines, or the label determines the bit. Here in the polar scheme, high voltage is what, or the positive voltage is 0 and negative voltage is 1. Okay, now here the positive voltage, suppose we will represent 0 1 0 0 1 1 0, then here 0 is already we discussed positive voltage, so 0 is this, we can represent this. Then 1 means that is a negative voltage, 0 means positive voltage, then 1 means negative voltage, negative voltage, negative voltage. Okay, then positive voltage. Okay, so this is what the energet L scheme. Next come to energet I. So this is non-return to 0 inversion. Inversion means change. Here the label will be changed. Okay, so, or the signal will be changed in the middle of the bit or in the starting of the bit. Okay, so now this is energet I. Suppose we represent 0, then here it is positive voltage. Okay, now if there is no change, then it is 0. If there is change, then it is 1. Again, no change means 0, change means 1. Okay, now 0 means here no change. Okay, 1 means change. अगेन 0 मीन्स नो चेंज, मतलब लेबल में कुछ भी चेंजेस नहीं हुआ. देखो यहाँ पे कुछ भी चेंजेस नहीं हुआ. 0 0, देन 1 1 आया, फिर यहाँ पे क्या होगा, चेंज. 1 आया, फिर यहाँ पे चेंज हुआ, फिर 1 आया, फिर यहाँ पे चेंज हुआ, देन इट इज 0. सो दिस इज व्हाट द एनर्जेड आई. okay, so this is what polarized energetic scheme, polar energetic scheme. Okay, next in polar scheme we have another technique, that is return to 0. So return to 0 means there is a problem with energetic. If the sender and receiver clock are not synchronized, then there will be problem. Receiver doesn't know when the bit will be started, when the bit will be ended. Okay, so we have the solution, that is return to 0. It has 3 voltages, positive, negative and 0. Positive, negative and 0. Okay, so and the signal it changes in between the bits. Bit के दौरान ही वो change होगा. For example here 0 1, suppose we will represent 0 1 0 0 1. then देखो यहाँ पे 0 0 means here if the 0 is represented like this, 0 is this, come to the 0 position, negative voltage, then come to the positive voltage 1, then 0 means this, 0 means again, means here this is the non return to 0. Every time it will come to this 0 label. Okay, this is negative label and this is positive label. Here 3 labels are there. Then come to biphase. Okay, now we will clear more about here the adject scheme. So biphase scheme is of 2 types, Manchester and differential Manchester. Manchester is the combination of RZ plus NRZ L, and differential Manchester is RZ plus NRZ I. Okay, RZ plus NRZ L is Manchester technique, and differential Manchester is RZ plus NRZ I. Okay, now suppose in polar scheme we assumed 0 is this signal and 1 is this signal, this digital signal. Okay, 0 is high to low and 1 is low to high. Okay, now come to Manchester. Manchester means already we discussed RZ plus NRZ L. L means label. Okay, so 0 means here 0, ये 0 जो लेबल था वो लेबल में आया. 1 मीन्स वो अपना लेबल सही किया, फिर 0 मीन्स वो लेबल हाई टू लो, 0 मीन्स अगेन हाई टू लो, 1 मीन्स लो टू हाई, again 1 means low to high. Okay, clear. Next, differential Manchester. Differential Manchester is NRZ I. I means inversion. Each time it will what? During the bit it will invert it change its position. Okay, so now 0. Okay, so this is, suppose it is started like this, 0. 1 means here change, so it will change its bit, change its position. मतलब कैसे स्टार्ट हुआ था, ऐसे स्टार्ट हुआ था तो वो चेंज होके ऐसे स्टार्ट होगा. फिर 0 मीन्स नो चेंज, तो कैसे चेंज था, कैसे सिग्नल था, अभी ऐसे ही था तो वैसे ही रहेगा. ओके, देन आया क्या 0, फिर वही सिग्नल है, देन 1 मीन्स यहाँ पे चेंज होगा, तो ये जो ऐसे था हाई टू लो अभी क्या हो जाएगा, लो टू हाई हो जाएगा. फिर 1 मीन्स अगेन चेंज, मतलब अभी लो टू हाई था तो क्या हो जाएगा, हाई टू लो. Okay, so in this way we can represent Manchester and differential Manchester, that means biphase technique. Okay, again it may be difficult for you, so I'll repeat it again. Manchester is NRZ and RZ plus NRZ L. RZ मतलब each time it will return to 0 position. Okay, and NRZ L मतलब NRZ L मतलब L मतलब label. Okay, so देखो 0, यहाँ पे हम लोग ऐसे इन्वर्शन लिए हैं, मतलब लो टू हाई टू लो इज 0, लो टू हाई इज 1. Okay, so for Manchester scheme, high to low is 0, low to high is 1, high to low is 0, low to high to low is 0, low to high is 1. 1 यहाँ पे है तो क्या होगा, लो टू हाई होगा. ये हो गया मैनचेस्टर. डिफरेंशियल मैनचेस्टर कैसे होगा? नाउ सपोज यहाँ पे हम लोग का 0 ऐसे लो टू हाई है. ओके, लो टू हाई से स्टार्ट हुआ है, लो टू हाई. ओके, नेक्स्ट 1 में क्या होगा? 1 में क्या होगा, क्योंकि डिफरेंशियल मैनचेस्टर में हम क्या बोले थे, आरजेड प्लस एनआरजेड आई, मतलब इन्वर्सन होगा. सो 0 मतलब यहाँ पे ऐसे जो लो टू हाई था अभी क्या हो जाएगा, हाई टू लो हो जाएगा. तो हाई टू लो हो गया. फिर क्या है 0, तो यहाँ पे कोई चेंज नहीं हुआ, मतलब क्या है पोजीशन अभी हाई टू लो है. तो अभी क्या होगा, अगेन हाई टू लो. फिर क्या है 0, मतलब वही हाई टू लो. फिर 1 है, 1 मतलब यहाँ पे क्या होगा, वो चेंज हो जाएगा. तो हाई टू लो जो था अभी क्या हो जाएगा, लो टू हाई हो जाएगा. फिर क्या है 1 है, तो अभी क्या हो जाएगा, वही चेंज हो जाएगा. लो टू जो हाई था अभी क्या हो जाएगा, हाई टू लो हो जाएगा. ओके, सो दिस इज हाउ द सिग्नल digital bit is converted to digital signal through unipolar and polar scheme. Okay.